So things have started getting busy here at the show now, and I've come over here to meet with Chris Sage, who is Technical Director at A-Star Education. How are you doing, Chris?
Oh, very well, thank you.
So you're here to share something quite new and exciting with the visitors, and it's all based around coding. So maybe first of all you could tell me, why is coding so important?
Well, coding's important because a lot of jobs now and in the future are going to rely on building and using computer programs. It's been recognised as important to be taught at both primary and secondary schools, and it's also a key part of problem solving.
Your product is called Code the Curriculum. Tell us about it.
Well, Code the Curriculum is a full coding environment which actually allows students to create their own projects. They can build their own tools, they have complete freedom, and one of the things about it is it's designed to help students get started in a very low stakes context. As well as that, we provide over 100 projects which start from simple drawing tools and animations to going through to the advanced stages where we show how to build complex simulations and also tools for solving things. So the idea is to make it useful.
What we're talking about here is real curriculum-linked learning. What kind of projects can you offer?
So we call them introductory, intermediate and advanced, and they relate very roughly to key stages 2, 3 and 4. So at key stage 2 we do things like drawing patterns with turtles and building shapes and animations, and then by the time we get to the advanced courses we're looking at building systems that are used in A-level physics and also for solving maths.
Okay, we've all seen coding environments before, but this is something new. What makes Code the Curriculum different?
Well, as the name suggests, what we're actually doing is trying to integrate the STEM elements directly into the coding. So there's two parts of it. One, coding actually requires a lot of maths and things like that, and so we actually encourage the use of the mathematics in the projects. And secondly, the projects themselves are actually used to help solve maths and physics problems.
And you talk about real-life problem solving. What does that actually mean in practice?
One of the things we do is we place an emphasis on simulating real-life systems. So one of the projects actually simulates a petrol forecourt where you set the prices and the rate of fuel flow, and it actually builds the whole terminal for you and you can fill a car up. We also have a way of doing a checkout as well, which prints a receipt. And the idea is that students get to see how these real-life systems might actually be programmed.
That does sound great. It sounds really engaging, and I can see how the children would relate to that. But I'm thinking that when it comes to building things, what they really want to be building these days is apps. Can Code the Curriculum support that?
So we provide a whole range of components such as text boxes and sliders, which mean that they can actually build interfaces for games and apps, as you say. We also provide a series of specialist tools such as compasses, rulers, things that you find in the classroom, which allow you to build more bespoke sorts of applications. So for example, they can do an app that bisects an angle, and they can even build their own graphing calculator.
Okay, so the million-dollar question, I guess, how does it work?
It's got a simplified and streamlined language, and the idea is that to give it some immediacy, for almost every single line of code that's written, it produces an immediate result for the students. And it's text-based because one of the things that teachers struggle with is this transition from block-based to text-based coding, and it's something that they have to do because all commercial software is written in text-based languages.
How easy is it for teachers to get started with Code the Curriculum?
There are 3 courses, and each course comes with a project guide which covers all of the projects in detail. And these are provided as e-books, so they're available to the teachers, but they're also available to students as well as parents at home.
So given that this is such a different way of teaching coding, perhaps you can tell me a bit about the thinking behind this approach.
Well, the idea of providing the source code for working programs means that the students can see the final project in action first, and it means they can almost work backwards, so that they can break it, change it, build on it, and they get a real idea of what's going on under the hood.
And Is there a collaborative element to all of this?
Absolutely. The files that are actually saved as text files, normal text files, which means they can be emailed and shared and imported and exported, and they can actually be used with any text editor.
Teachers are going to want to know why this is such an effective approach from a teaching point of view. Can you talk a bit about that?
Well, we have a large number of projects of varying difficulty. So concepts like sequence and selection, loops and variables can be demonstrated with projects that are just a few lines of code, while the larger projects show how these ideas come together to produce impressive results. The number of projects means that coding lessons can be differentiated very easily without extra workload for teaching staff. And the documentation that's provided means that the teachers have ready to hand the answers to the students' questions.
Okay, it's clear you've got something new and interesting and exciting to talk about here. You probably want to get on and talk about it with all the visitors to the show, so I'll leave you to get on with it. Have a great show, Chris, and thanks for talking to us.
Thank you very much.